let's just talk a few minutes about microservices. And one of the key points about microservices is that they allow you to realize the full benefits of cloud native. And you saw some of those benefits right there with the ability to, scale different workloads automatically, and then to also, also have load balancing across these components, and then also the ability to update them with zero downtime. So microservices are, again, the style that allows you the full benefits. But in terms of following up from our initial sort of approach where we talked about, replatforming, and then sort of intermediate step was this idea of repackaging. And this is sort of the recommended way. So, if you need to modify the legacy apps, it's better to take small baby steps than to spend, weeks or months trying to sort of refactor everything and, and then, deploying it to validate whether or not your approach is warranted or not. So when you repackage the microservices, what we're saying is this, start off with sort of kind of a broad definition of what a service is. It may not be your final destination, but it's a good starting point. And generally speaking, with these exercises, it's much easier to recover if your service boundaries are too broad. You can always iterate and sort of refine them and make them smaller. But typically, if you start from the bottom up and try to, define your service boundaries and then build up that way, if you do find out later on that the service boundaries are not appropriate, or you just kind of missed some important things, then it's usually much more expensive to recover. In a lot of cases, you end up having to just start from scratch. So again, repackage the microservices. And what that means is looking at the application and looking for natural boundaries, component boundaries. With legacy JEE apps, for example, you may have separate WAR files, different components in WAR files. Or you may just have one large WAR file, but within that WAR file, there will be sort of easily identified component boundaries. And those all can be separated and migrated separately into different containers. And as far as your middleware is concerned, you can also look at partitioning that. Generally speaking, most people have the most problems with databases, especially legacy databases that have evolved over time. This is usually not that easy to find nice, clean partitions to break it up. So that can be problematic, but in some cases you can find those partitions. So you can also move those over as well if it makes sense. In this case, we're using an example of IBM MQ, where part of the MQ infrastructure was used by the migrated components to communicate with each other. So that's sort of low-hanging fruit for migrating to a container. And then the rest of the MQ infrastructure that is typically used to communicate with the rest of, other applications within the enterprise can be left as is. So microservices are a kind of interesting thing. There is no single definition that will tell you exactly what a microservice is, but there are some characteristics that pretty much all microservices implementations share. So let's just briefly go over those. So the idea is that, in terms of migration, what would be a normal app, what today we call a large monolith would be broken down into many small services. Each service runs in its own process. There's typically one service per container. Your services are optimized for a single function, so it's one business function per service. And this makes them more sort of agile because the service now only has one reason to change. Tightly encapsulated behind concrete programming interfaces. And one of the challenges there is that you need to balance between, evolving the interfaces as needs change, or as the clients of these services have additional needs, but you also want to maintain backward compatibility as well as much as possible. Communication via REST APIs and or message brokers. So REST APIs would represent what we would call synchronous communications. So people would call your service, or application components would call your service and get responses back immediately, either success or failure. The message broker style is more flexible. It's more of an asynchronous way of communicating. Advantages there is that services can be down and not miss calls, and just more flexibility for scaling and so on. The disadvantage there is error handling becomes problematic, because when things are being delayed into the future, it's very hard to notify the original caller of an error that may happen 2 or 3 hours down the road. Per service continuous integration and continuous deployment, CI/CD. So that's really important. Microservices have become, first-class citizens of the development shop, and they can be tested, deployed independently and separately without any dependencies on the testing and deployment of other microservices. And then you can do per service HA and clustering. So now you have a lot more flexibility and granularity, because you don't, instead of having to scale an entire sort of monolithic app, you're only scaling the parts that need to be scaled. And in the case where multiple parts need to be scaled separately to achieve optimal throughput, you can do that. With large monolithic apps, you only had, and we'll see later on, only had one way to scale them, the whole app. So it gives you a lot more flexibility, and essentially costs more, because you can scale smaller parts of the original app and only scale them as needed. So just the fundamentals of the key takeaways of microservices architectures is really about breaking down, in terms of migration. Again, it's about breaking down these large silos into these manageable, decoupled pieces. Encapsulation is key. The related logic and data should remain together. So you need to have these strong service boundaries between the microservices, and by strong we mean they don't change. And there are techniques you use, again, you can evolve interfaces but not break backward compatibility. Martin Fowler of ThoughtWorks has written a lot about microservices patterns and architectures, and he has a pattern. He's mentioned a pattern called it's the tolerant reader, which essentially gives you some nice tips and techniques to follow in order to make your interfaces as robust as possible, with the capability of evolving without breaking backward compatibility. And then finally, the relationship between APIs and microservices. There is not necessarily a one-to-one sort of relationship between them. So for example, in the past, you may have had a siloed application that exposed an API. When you migrate that, or when this is rewritten in a microservices style, you can maintain the same API, but it may be spread across multiple microservices. So again, APIs and microservices don't have to be at the same granularity. They can be, but in some cases it may make more sense to have one API be spread among multiple microservices.